I don't even care which one we start with. Just give me a piece of information about one of these three types of naming. We'll kind of just build our list as we go. Okay, what's something specific you know about each of these, one of these types of naming? Yeah.
In ionic naming, you have to have charges balanced, so there's no
Good.
charges in the name.
Good. It's a neutral compound. No charges left over. Okay, good. Yeah, go ahead, Brennan.
Ionic is non-metal and metal.
Good. I'm going to list it the other way because the metal comes first. So it's going to be a metal and a non-metal. Very good. Okay, or we can think of that as cation and anion. Those two things have to be bonded. Okay. What else? Give me some other information we know about one of these three categories of naming.
Isn't it like acid has to have like hydrogen?
Good, good. Acids begin with hydrogen, right? They always begin with hydrogen. That's how we know that it is an acid, and we can use our little cheat sheet to help us name that. You might want to grab that little cheat sheet out if you don't have that yet, the little acid half sheet. Okay, but they have to begin with a hydrogen.
Covalent is two non-metals.
Good. Yep, covalent is two non-metals. Two non-metals. Okay. In which of these three categories do we use the prefixes? Ionic or covalent or acids? We use the prefixes only in covalent. All right, and when I say the prefixes, I mean mono, di, tri, etc. Right? Dot, dot, dot. Right, I use the prefixes when we're talking about covalent compounds. Do I ever use prefixes in the other two? No. No. On our homework, I remember one specifically was was gallium. No. I'm going to write it up. It was this. This was the formula, GaCl3. And a lot of us on our homework put gallium trichloride, right? And that doesn't work because gallium is a +3 and this is a -1. It's not gallium trichloride, it's just gallium chloride, right? It's an ionic compound, so we just named the metal and then the non-metal, right? We have to know when it's an ionic compound because of the fact that it has a metal or a cation in it. Okay, so we need to be really careful with that. That was one that was really common on that homework that we did. So what does the overall charge of an acid need to be? They need to be neutral as well. It's a neutral compound. We're gonna combine hydrogen, which is H+, with some anion to form a neutral compound. Which of our categories might we have to use the Roman numerals with? Ionic. So this one is possible use of the Roman numerals. Which one of our sets of categories would we need to use the crisscross method for? Ionic. Okay, in which one of our categories does the charge not really matter at all? Covalent. Okay, because those are two non-metals. So charges don't matter, right? No crisscross there. Okay, so there's kind of our breakdown. Is there anything that we need to add to this crash course here of our three types? I think we kind of hit everything. Let's go ahead and just try some here, and then we're going to do a little bit of partner work with it. Okay. I'm going to give you 3. And you're going to write the formula for them. All right, so I've got 3 up there. Can you read those okay? Okay, do you want to be able to see the little 3 breakdowns up there? Is that helpful, or do you have those in your notes? Okay. All right, Riley, what do we have for bromous acid? HBr. It needs to come from bromite. So we're going to have to find bromite up in the box, which I don't know if it's up there, right? Bromate is up in the box, but bromite is not. So how do we know bromite?
It's
One less oxygen. So it would be HBrO2. How do we feel about that? Okay, that required us to do a couple extra steps there. Bromous means it must have come from bromite, and bromite's not in the box, but bromate is in the box, and we need to take away 1 oxygen from that. Okay, so it should be actually, I made that, that's wrong, H3BrO2. How about that? Because bromate is BrO3, no, I'm wrong. I read it wrong on my box. It's just HBrO2. Sorry about that. I was looking at another one. HBrO2. Did anybody have that?
I
Yeah.
actually have the hydrogen chloride for that.
Okay, yeah, we got to have that. That's what makes it an acid. Yep, very good. Okay, how about this second one? Calcium iodate. So tell me, do we agree or disagree? We're close, but what should it be? CaIO3 2. There needs to be 2 of those iodates to be able to cancel out my calcium, because calcium is +2. Iodate is IO3 -1, so we crisscross.
I just forgot how to put it. I knew it was supposed to be more, but I didn't know how to write it. So
Yep, we have to put parentheses around that iodate to show that we need more than 1 of those. I didn't ask about the categories here. What category is our first one? It's an acid. Our second one is ionic. And how about our third one? It's covalent. So SiO2. No crisscross, not adding anything else. We're just reading that one exactly as it says. Okay? Let's try and go backwards now from the formula to the name. Okay, so let's go from the formula to the name. So this one I'm going to give you... All right, I've got 3 listed there, 1 of each. Let's go ahead and figure out what they are. The written name. We're almost there. Nickel chromate, but what are we missing for nickel specifically? It needs to have a Roman numeral. It needs to have a Roman numeral. So the Roman numeral that needs to go with nickel, what do we think? Is a +2. Right? We know it's +2 because we know chromate is -2, and in order to cancel that out, nickel has to be +2. So our full name has to be nickel 2 chromate. Agreed? Did some of us have that? Good? Okay. The next one, is it ionic, covalent, or an acid? It is covalent. Good. This one is called
Tetrasulfide, tetranitride.
tetra. What'd you say on this one? Tetrasul. It's actually going to keep its regular ending. This one's tricky. Tetrasulfur, tetra, and then nitride. Yeah? Yep. This one's tricky. Tetrasulfur. And I know on your periodic table, it doesn't even give you the option of sulfur, does it? Right? On your periodic table of ions, it just automatically says sulfide. So we remember that for covalence, the first element keeps its full element name ending. Okay, so that's a little bit tricky. So tetrasulfur, tetranitride. Why does the first one get a prefix in this example? Because there's more than one. We wouldn't say monosulfur, tetra, right? There's 4 of them, so we have to put the prefix on if there's more than one. So tetrasulfur, tetranitride. Okay, it's kind of a mouthful. How about our last one? Is it ionic, covalent, or an acid? Acid. Good. Okay, Brendan, what do you think?
Hydrophosphoric acid.
Phosphoric acid. Again, I wouldn't have counted off if you just put the ick, you moved it up a little bit. Not the end of the world, but that's technically where it goes. You got your prefix and your suffix right, so I'm happy with that. Okay, but hydrophosphoric acid. Did we remember to get the hydro-ic, right? Because it came from just the phosphide ion, not phosphate or ite. Okay, good? Very good. All right. Good. We're here's some mumbling, but for the most part, sulfurous acid.
I didn't spell it right, but
That's okay. Did we put the OUS on the end at least? Okay, good. Remember we said our suffix tends to go after the R. And that's kind of our rule. It's not a huge rule. Yeah.
Why is it hydrogen too?
Because sulfite is SO3 minus 2.
Oh.
And so if I'm going to pair hydrogen with that, I need 2 of those to add to it. Okay? Yep. Sulfurous acid. Very good. Second one, is it ionic, covalent, or an acid? Ionic. Good. Okay. This one is called just what? Cobalt sulfide. Cobalt 3 sulfide, right? We got to reverse the crisscross. That leaves us with plus 3 and minus 2, which we know that is sulfide's normal charge, so it must be plus 3. Good. Last one is covalent. We're going to name it what? Iodine monochloride. Very good. Iodine monochloride. So no prefix, regular ending. Yes, prefix, not regular ending. Okay, so we kind of give it a little switch there. Okay. Okay.